Hey, welcome back to Math with Patrick. It's March 30th, and we have problem 89 from this Daily Epsilon calendar to solve. And apparently, the answer is 30, and it just looks like it's an arithmetic problem. So we need to do some math steps to prove why this number on the screen is just 30. I see we have the cube root of 4 different things added up, and these are all going to be powers of 3, with this one being the smallest and this one being the greatest. So first, let's talk about what's a cube root. I'll give you some examples, how about? So the cube root of 8 is 2. And another way to think about this is when you're doing a cube root, you're trying to find some number out there. When I multiply it to itself 3 times over, I get 8. Anytime you have a square root or a cube root or any kind of root, you can always rewrite it in exponential form. And so if you are content and happy with 2 times 2 times 2 being 8, that's the same thing as saying that the cube root of 8 is 2. Since we're working with 3's, some other important cube roots that we might come across would be the cube root of 27. That's because 3 times 3 times 3 is 27. Besides that, I don't really have many other cube roots memorized. I mean, the cube root of 64 is 4, because in other words, 4 times 4 times 4 brings you to that 64. And actually, let's talk about another way to think about cube roots. So let's actually do that cube root of 64 again. If you're able to factor your inside number, and in the case of a cube root, if you're able to find a triplet, then they can kind of like escape the cube root sign altogether as one group. And this way of thinking about cube roots is really useful if you're trying to find maybe a simpler version of, say, the cube root of 128. This is going to be really, really close to 5, because I know that 5 times 5 times 5 is 125. So this is almost 5, but not quite. And another way to do this is to do some factoring. I know that 64 times 2 is the same as 128. And then if we continue factoring down that 64, we get those 4 times 4 times 4s, those 3 4s all together. And then these 3 can escape the cube root sign together as 1. So this value and this value are the same. You could try it out in a calculator, but this is just considered a more simple form because we were able to take out some extra stuff underneath that cube root sign. So that's probably going to be my goal here, where I want to try to find some common factors and see if I can take them out of that cube root sign. So I'll rewrite it. I got the cube root of, and then I notice that all of these have 3 cubed as a factor. So if I factor out a 3 cubed, I want to figure out how many more 3's I have left in each of my addends, or each of the things being added up. I have 6 more 3's here. I have 5 more there. I have 3 more there, and then I have none here. And so you could maybe imagine if you distributed this 3 cubed back in, then you would return back to what we had before. And I guess 3 to the power of 0, that's just 1. That just represents no 3's being multiplied together. So I've already found a triplet here. This 3 cubed is allowed to escape as just 1 3 on the outside of the cube root sign. But then I'm still left with this 3 to the 6th plus 3 to the 5th plus 3 cubed plus 1. And I don't see anything else really like striking to me about this. Like I factored, great, I got a 3 out. Apparently this number is supposed to be, it looks like 1,000, because again, my goal is to get a 30 out of the problem today. So I'm really hoping to get a 10 times 10 times 10 out of the stuff underneath the cube root sign, because then if I find that triplet, they'll get to hop out together, and then the 3 times the 10 will be 30. But nothing is obviously a 1,000 to me. Maybe like keeping that idea in the back of my mind. Looks like this is going to be the number 999. And I guess I should just do a little bit of arithmetic and figure out why that's the case. So no funky tricks here. I'm just going to figure out some powers of 3. Well, 3 cubed is 27. So if I multiply another 3 to that, I get 81. Another 3 to that is going to be 243. Another 3 to that is going to be 729. I just happen to have powers of 3 memorized up until that point. Oh, and then, why not? Let's add on this 1 there. Okay, 9 plus 1 makes a 10. 3 plus 7 makes a 10. So overall, that is 20. 2 plus 2 plus 2 makes 6. 6 and a 4 make a 10. And then 9 plus the 1 that I carried makes another 10. So ultimately, this is the number 1000. And once we take the cube root of that, again, cube roots ask what times what times what gives us the number underneath. And that is just a 10. So finally, once you do the 3 times the 10, you get 30 for the day. So there's my solution for answering this problem, and we're all done. Thanks for coming along, and I'll see you tomorrow. All right, bye.